Hi, this is Sam Michel. This essay is entitled Hopefully Right and Homeless. Not that I want to be homeless, I am, but it's not really tongue-in-cheek. If I have to run to the CR, well, that's life. Yeah, I'm feeling it, but dated October 27th, 2023. It's a kind of synopsis essay. I've gone back and forth between, convention and some unconventional ideas quite recently. I mean, I call it pendulum swinging because it seems to be like a pendulum swinging back and forth. I mean, I try so hard. I try so hard to understand conventional viewpoints and the reason that science is the way it is, rationally, and not skeptically, like always assuming that people are trying to make money and grift and stuff. I hate that attitude because it's just, it's not very trusting. That attitude is not very trusting. It makes scientists look like con men, and I don't like that attitude. But anyways, to get back to the essay, Hopefully Right and Homeless, dated October 27th. General relativity is about masses curving space-time. The Standard Model and quantum field theory are about reductionism and assuming forces at quantum scales are bosonically manifested. There's nothing wrong per se about either, but the conventional approach of the latter, as I understand GR, is simply inapplicable for GR. For many decades, theorists have worked on a graviton, meaning there's different kinds, a theoretical bosonic approach toward GR, and gravitino, a supersymmetric version of the graviton, in an effort to theoretically unify the four forces of nature at extremely high energies, assuming two things, at least two things. Energy densities in the early universe actually were such, at very high energy densities. Those energies allowed actual physical unification of the four forces. The first assumption is sound. I mean, most people agree that, if you turn back the clock, reverse the current accelerated expansion in time toward the so-called beginning and keep, winding back the clock. It's taking the current state of the universe, it's this accelerated expansion, and reversing it. And it ends up being almost like a point, right? They call it the singularity, but anyways, that's a little difficult to work around, but they found ways like inflation and stuff. Imagine you're boiling a pot of stew in a pressure cooker. This cooker is very special. It allows you to crank up the heat to any desired level such that you can separate molecules and determine the energies of dissociation for the molecules. You crank it up further out of curiosity. At some points, you determine the dissociation energies of separating atoms from their electrons in their orbitals, ionization energies. You continue to crank it up to determine nucleonic dissociation energies. You can even past that, you continue to crank it up to determine if you can break down protons and neutrons into their components. But all you obtain are very short-lived particles. You reduce the temperature slightly and observe only three things: protons, electrons, and antineutrinos. In the process of observing and taking notes, you determine there are only three types of binding energies: molecular, atomic, and nuclear. Different for each type of molecule, atom, and nuclear species, meaning that the binding energies are going to be different for each type of molecule, each type of atomic nucleus and orbital set, and like carbon and oxygen, and for each set of nuclei or nuclear species. You compare notes with a conventional physicist and have several questions, well, at least two, for them. Why do you claim that there is a weak force? I observed no such thing at any point in my pressure cooker experiment. Further, why do you claim that there are such things as quarks? Those as well I never observed. The reader should understand fully that both the weak force, in quotes, and quarks are theoretical contrivances. The weak force, in quotes, was invented to explain radioactive decay. Quarks were invented to explain the short-lived particle ZOO resulting from atom smashing experiments. Absolutely none of those particles are stable. Pions, mesons, vector bosons, W's, in quotes, vector bosons, quotes, in quotes, Z's, the Higgs boson, in quotes. The reason I put those titles, and they patently are only titles, in quotes, is because, yet again, they're theoretically assumed to be weak carriers, in quotes, and hypercharged carrier, in quotes, when they could simply be short-lived decay products that show up more often than not. Please understand that I have tried for many years to reconcile GR with the Standard Model, trying my best to assume I was wrong about above, year after year of trying my best to assume I was wrong and convention was right, year after year futilely attempting to reconcile the irreconcilable, GR and the Standard Model, always ending up in disappointment and self-recrimination. Maybe I'm not smart enough. Maybe I don't know enough. Educating myself as best I could to truly comprehend conventional viewpoints, to end in this, homeless metaphorically and literally, dejected and marginalized, all along trying to best fit in while never invited. We award prizes and commendations, layer prestige upon honor for what? For towing the status quo, for kowtowing toward convention. Personally, I'd rather be right and homeless than wrong and not. Dated 2023, October 27th. Now look, I'm going to make this as long as I need to, this essay. I mean this video essay. I'm not going to read it again. The thing is, and I understand why convention has gone the way that they have. It's reductionist, it's bosonic. It's trying to explain things from a carrier point of view, like assuming that the weak force is mediated by carriers, the W and Z's. And then that they further are what? Based on the Higgs. And it makes sense from their framework, their point of view, their framing of the issues, let's put it like that. They don't even have to be classified as problems, they're just issues. Like the particle zoo, trying to understand radioactive decay from a, well, from a reductionistic, while at the same time holistic perspective. I mean, it is reductionistic, but at the same time it is somewhat holistic, because they're trying to understand radioactive decay from a, as a process, as the opposite of fusion. There's nothing wrong about that first assumption, absolutely nothing wrong. It's like I said, you turn back the clock of time, and things get denser and hotter until you get to the point where what? I mean, things are what they call a quark gluon plasma. The thing is about quarks, you can never isolate them. They at least always are in pairs, which I think those are called pions. But anyways, they're at least in pairs, at least. Can never be isolated, ever. By their own, what do you call it, framework and their own framing. Their own framework. Quarks are unisolatable, at least in pairs, and usually in triplets. I mean, according to their framework, and the triplets are protons and neutrons. The reason I say that the second is not sound is because GR is about the curvature of space according to, the presence of masses. And that's it. That's it. It doesn't say anything about bosons, I mean, when Isaac Newton and Einstein formulated first the laws of attraction between gravitating body, between masses, was Newton's work, and then F equals ma, and the gravitational equation about determining force between gravitating masses, celestial masses. And Einstein further determined what? It was space-time that was curved, and not really about a force, but more about the curvature of space-time due to the presence of mass. That idea right there, I mean, if that had been developed, say, 100 years prior to quantum mechanics, let's say it had been developed, like Einstein's work had been done even 100 years earlier, back in the early 1800s, things might have been different. Things might have been a lot different, coming from the GR point of view. Trying to understand particle physics from a GR point of view is completely different. Completely different. So, it just so happens that that particle physics, or the theory of particle physics, like the roots of the Standard Model with Max Planck, happened around the same time as Einstein was developing his GR, around the same time. So, fortunate or not, that's the way it happened, and they didn't use a GR approach for understanding the basics of particle physics. Did not. They could have, but they didn't. I tried my best, but it's not just that it's irreconcilable. The two areas it's just that, I tried to approach particle physics from a GR standpoint, and there's no way, I realized in the process of doing it, there's no way that convention is going to accept that, ever. Because it's non-bosonic, and just dealing with the curvature of space-time. Like, for instance, you can look at a nucleon as with just curvature. Other than if it's a proton having charge and magnetic moment, other than those other properties, the electromagnetic properties, it possesses, it produces curvature by its presence. So from a GR standpoint, you could start modeling nuclei based on the so-called binding energy being that of curvature, which is what I attempted recently. But again, nobody's going to accept that. Nobody's going to accept that. Most certainly not a conventional scientist. The pressure cooker idea is excellent because I spontaneously came up with that because it's just, it's the simplest approach toward understanding binding energies, is by increasing, a hypothetical pressure cooker where you can disassociate molecules and then atoms and then nuclei, and then try to break them down further. As we demonstrated with this thought experiment of this incredible pressure cooker, Nowhere does the weak force show up in that thought experiment. Nowhere does it show up. I mean, I think you'd have to play with neutrons back and forth, allowing them to recombine into the components of a neutron to recombine, and then, trying to observe possibly internally what's happening, if it's possible, to observe internally what's happening inside a neutron as it disassociates into components, always the same three. Proton, electron, and antineutrino, always the same three. It's an oddity of nuclear decay because, other nuclear decay is not like that. Other nuclear decay has branching fractions and probabilities of branching, Other nuclear decay is not like that. It's a standard, but it's it's atypical for most nuclear decay. And that's why, quantum mechanics and particle physicists, they treat it differently. They don't treat it as an archetype. I do, but they don't. I treat it as an archetype, they do not. It's very, very different from most decay schemes, in that it always turns out to be a proton, an electron, an antineutrino, always, every single time. And that's why I consider those three things basically elementary particles. In nature, observing natural things, you're only going to observe those three things at high energies, or combinations thereof. Astrophysicists who monitor cosmic rays and stuff, high energy protons, antiprotons, possibly anti-deuterium, and even up to anti-helium-4 in cosmic rays. So in other words, we get both, in cosmic rays, we get extremely high energy protons, antiprotons. I believe we get deuterium and anti-deuterium, and rarely we get helium and anti-helium, and high energy cosmic rays, but they do happen. So this is where I continue with the pressure cooker thought experiment. And I know the answers. I know the answers. If I was the conventional physicist, I would say, well, I claim there's a weak force because we model like that, bosonically, and the carriers of the weak force are so-and-so, and they're based on the Higgs. I would just give them exactly, the conventionally accepted answers. Why do I claim that there is such thing as quarks? Because that's, to make sense of the particle zoo. I would just give them back the reasonings that, of what I say later on. The reason I use the word invented is because that, let's say the difference between an invention and a discovery. Edison supposedly invented the tungsten argon light bulb. He didn't discover it, he invented it, right? What about GR versus the Standard Model? Are they both discoveries, or are they both an invention? I treat GR as a discovery because to me, it's about the truth. In a sense, because the tungsten argon light bulb is one of the most, long-lasting example, incandescent light bulbs possible, you could say he discovered that. Why not? You could say that Edison discovered the tungsten argon incandescent light bulb is a very long-lasting example of an incandescent light bulb. Of course, you could say that. But it really, when you start getting toward, for me personally, when you start getting talking about the Standard Model and concepts within the Standard Model like quarks and gluons, which are theoretical binders between nucleons, right? Gluons, bosons, part of the bosonic framework. To me, that those were inventions to explain things, like the strong force. Gluons were invented to explain the strong force, to me. And weak carriers were invented to explain the weak force. From a systems point of view, you don't need them. From a systems point of view, you don't need weak bosons. They're just unstable dynamical systems from a systems point of view. Those nuclei that decay are just simply examples of unstable nuclei from a systems point of view, a dynamical systems point of view. As I've had training in that. I don't need a weak force. I simply look at unstable nuclei as unstable nuclei. They're going to decay at some point because they're inherently unstable. As are pions, mesons, vector bosons, and the Higgs. Those are all, to me, examples of unstable nuclear systems. All five of them. Two are categories or classes of unstable nuclei, and the other three are, they're viewed by convention as mediators, but to me, intermediate decay products. That's all they are, intermediate decay products. So I get a little, not arrogant, but a little, scolding in a scolding mode. They're just titles, man. They're just titles. They're just titles. It doesn't, it's like, it's like giving an award to a horse that just won a race. But what if that was the last day of its racing days, man? What if that day was the last and the horse knew it? And the horse knew it. And you just gave the horse best of show. And he says, man, I wish you'd give it to somebody else because today's my last day, man. Today's my last day. I don't know if you understand the analogy, but somehow my mind came up with that. My brother won best of show in a pottery thing in high school. Well, it was best of show among many different types of artwork, but he won because his was beautiful. It was a pot, I remember it, the way it was glazed and stained and glazed. I mean, it was just incredibly beautiful. And an attendee bought it for like $100, and mom or somebody said, you better buy that back because, and the guy let John Paul buy it back for his own memories. You better buy that back for yourself, man, so that you don't forget that you won best of show. Yeah, it's a little personal story that for some reason came up. Maybe because I brought up the idea of best of show at a horse race thing. Anyways, the thing is, man, so look at how I end the essay. Maybe I'm not smart enough. Maybe I don't know enough, Maybe I haven't learned enough, to help them unify their frameworks, the GR framework and the Standard Model framework based on quantum field theory. Maybe I just don't know enough. Maybe I'm not smart enough. Or maybe they're just ununifiable. Maybe they're simply ununifiable. Well, I hope you enjoyed this essay. I enjoyed making it. May your God bless you in your lives and everything that you do.